Iceland, a geologic history, made and presented by yours truly, Julian Gauthier. Now let's get right into it. A lot of people wonder, where is Iceland? They don't really know where it is geographically. They don't know where it is in relation to a lot of other stuff, especially including Greenland. I think a lot of people are definitely going to be getting Greenland and Iceland confused. And, that's a very common misconception. So today, we're going to start off by looking at the plates that Iceland is located on, which the east part of it is located on the Eurasian plate, and the east part of the continent is actually a part of Europe, while the west part of Iceland is located on the North American plate, and the west part of Iceland actually is in North America. So Iceland is one of the only countries, if not the only country, I believe, to be located on two continents at the same time, which is a pretty interesting fact, and, pretty cool, I guess. If you live in Iceland, you could just have one foot on one side, one on the other. Pretty cool stuff. We've all imagined doing that as a kid, I'm sure. Yeah, but where is Iceland? It's located in different parts than just on a couple different plate boundaries. There's ridges that run through Iceland, specifically the Mid-Atlantic Ridge, which is a very big ridge in the middle of the Atlantic Ocean. And Iceland actually lies on this ridge. And as we get further into this presentation, you will be able to see that this ridge is one of the reasons that Iceland was actually formed. So we have a couple different pictures here. As you can see, this red line in the center picture is the Mid-Atlantic Ridge. And Iceland right here, you see it separates it just about right down the middle. And yeah, that Mid-Atlantic Ridge runs through South America and Africa. And yeah, it's just in the Atlantic Ocean. That's why it's called the Mid-Atlantic Ridge. Pretty much self-explanatory. You still can't find Iceland, It's looking a little bad for you, I'm not going to lie, because I've given you a lot of clues. But, here's some more. So the coastline of Iceland, it actually has a couple different bodies of water that it's surrounded by. So north of Iceland, you're going to get the Greenland Sea. East of Iceland, you're going to get the Norwegian Sea. South and west, you're going to get the Atlantic Ocean, which again, I just said. The Mid-Atlantic Ridge runs right through Iceland, so that does make sense. And then northwest Iceland, you're going to get the Denmark Strait, which is approximately 200 miles wide and splits Greenland and Iceland apart from each other. So, pretty self-explanatory there. They are definitely both islands of their own. They're not connected in any way. They are separated by that Denmark Strait, as previously mentioned. So now that we know where Iceland is located, let's, get a feel of what makes up Iceland. What's it made out of? What makes it so special? What's its composition? So Iceland is made up of about 90% igneous rock, which there are about 25 main types that you would find on the island. Definitely some more, but these are the main types that you're going to pretty much be finding anywhere you go on the island. Then there's about 10% sedimentary rock and 0% metamorphic, which is a little interesting, but yeah, 0% metamorphic is not made up of metamorphic rock. There's probably metamorphic rock there, but it is not, made up of it. So it is a basaltic mixture, which is igneous rock, and this is due to all of the, the hot spot and all of the volcanic activity that actually helped to create Iceland and, form it on that Mid-Atlantic Ridge where that hotspot pops up. And, basaltic mixtures is actually a great type of rock and, thing to form a country out of because it is very useful for things such as building roads. It is very strong, especially under pressure. It is just a very useful rock, and especially for creating infrastructure and society, which is why Iceland actually has a bustling society and a lot of people living there. So we just got to learn a little bit of what makes up Iceland. Let's learn a little bit more about its history. So starting off 20 million years ago, man, that is a long time. I'm 21, and I see 20 there. I'm thinking, I'm 20 million years ago, guys. All right, that is a long time ago. And 20 million years ago, we are going to be in the Territory period and the Miocene epoch. And this would be when Iceland's oldest region, which is the Westfjords, was formed. And the youngest parts of Iceland, which is Surtsey Island, which is actually one of the youngest islands in the whole world, it was only about 700,000 years ago. So 20 million years ago was when Iceland first started getting formed. 700,000 is when it was pretty much finished forming. I mean, it's still forming a little bit, potentially. It's moving, different things like that. But, this is when the main Iceland, parts of it and the makeup of Iceland was created from 20 million to 700,000 years ago. That is a long, long time, basically, for this island to be cooking up from, all the stuff previously mentioned and stuff that we'll mention moving forward in this PowerPoint. And so that is the creation of just the land masses of Iceland. And so we're going to jump forward here using this break that I've created in this timeline. And we're going to go jump forward to 874 AD. Pretend like it is Peabody and Sherman who just hopped in the time machine, zooming forward in time. And now we get a Norseman who was the first person to settle in Iceland with his family, which is awesome, guys. And then we get a little later on to the 800s. He brings a lot of Viking friends and stuff with him. They began to populate Iceland starting in the late 800s after my man Arnarsson, the epic Norseman who actually was the first one to step foot on Iceland. And they say that he actually laid out some logs and just pushed them out, and wherever they hit ashore, that's where he built his house, which they found remnants of, which is just awesome to me. And then a pretty cool fact that I found is that Parliament, which is a part of government that a lot of places use, including Britain is one of the biggest examples of them, they were the first actual country to invent a parliament, and they still have their parliament building to this day, which is very nice. And after we look at this whole timeline, we will notice that it is in the Cenozoic era, which is from 66 million years ago to the present. And after the break, we have these dates that take place in the Holocene epoch, which is 12,000 years ago to present, and the Quaternary period, which is 2 million years ago to the present. And again, the break is right here, right after Peabody and Sherman hopped into that time machine. So on we go. So now that we've seen, some of the history of how Iceland was created, the time periods, kind of just laid out that timeline of Iceland, we're going to look at some of the mechanisms that created and formed Iceland. So it was formed at a subduction zone. And those plates I was talking about, the North American and Eurasian plates, the ones that basically put Iceland on 2 different continents, they're diverging plate boundary, which caused a hotspot to form. And from this hotspot, a lot of volcanic activity, eruptions were coming up, causing a lot of sediment to be laid down and creating these rift valleys, which would eventually create more volcanoes, fill it in, and these valleys started to shift, and we now have these parallel fault lines that run through Iceland and, make it a big, spot for seismic activity. A lot of earthquakes are happening here, a lot of stuff like that. So yes, Iceland is a very, living, breathing sort of landform where a lot of stuff's going on there. Like I'm saying, a lot of seismic activity is going down, these parallel fault lines. Look at something like California. Got a lot of fault lines, got a lot of seismic activity, a lot of earthquakes. The ground's moving, it's grooving, it's shaking, it's quaking. You get the gist. So yeah, it's always moving, and it's just pretty much a living, breathing landmass. So I just explained some of the mechanisms that created Iceland. Now let's get a look at some diagrams here. So this is the mid-Atlantic ridge that Iceland lies on. Basically runs through the middle of it. This would be one of the final steps in how a mid-ocean ridge forms here. So as we can see, this is the mid-ocean ridge. The sediments are lining up. The Earth's mantle is down here, and the crust is pushing it. So now we're going to look at some of the diverging plate activity from the North American and the Eurasian plate that formed Iceland. We can see their movement which way the North American plate is moving, which way the Eurasian plate is moving, which is very nice. We can see that mid-Atlantic ridge that's cutting through Iceland right there. And they actually have a national park right here where you can actually go and visit right where that mid-Atlantic ridge cuts through Iceland. Pretty cool stuff. I'd love to go there one day. So, and yeah, so now that we have this final one right here. And this is basically showing the volcanic systems, all these black landmass things, or these black dots on this here, are the volcanic systems of Iceland. And this circle actually is the mantle plume, the hot spot, really where Iceland was formed. You can see it's pretty much in the same spot right here on that mid-Atlantic ridge. So that's basically the birthplace of Iceland, which is pretty cool. It's kind of like the umbilical cord in a sense if you look at it. And, you know, we've got this B section right here, which just basically illustrates what all these volcanic structures are going to look like under the ground and a little bit above the ground. So, yeah, it's very interesting stuff. A lot of volcanic activity, which obviously created Iceland and still goes on to this day. And now that will take us to Iceland's present situation. So, Iceland, constantly moving, as I said, it's basically a living, breathing landmass. It's always pushing northwest, which is, you know, pushing northwest. And the tectonic plates are shifting east and west. The North American and Eurasian systems are the ones that are pushing Iceland towards the northwest. And as I've been saying, there's a lot of seismic activity, especially since 2021 is really when the seismic activity started ramping up. And in 2024, there's been over 8 eruptions just this year, which is mind-boggling to me. I'm very glad I don't have to deal with that. The latest actually was only a little over a month ago, August 22nd. So, you know, that's the very recent, and I'm sure there will be tons more this year, by the way, that the year has already been going. With 8, I can only imagine there's going to be more. And next year and the year after. Just praying for Iceland and the families there, and just hoping they don't get affected too much by that. You know, Iceland is a very volatile spot, very volatile land. Lots of weather and natural hazards. Storms, floods, earthquakes, volcanoes, landslides, avalanches. Expect it all if you're going to go visit Iceland. And if you live there, I'm sure you've dealt with all of it, and I feel for you. Alright, so now that we've seen what's happening to Iceland as we speak, we're going to look at what's happening to Iceland in the future. Or at least what we think will happen. So, as, you know, a lot of people talk about global warming, this and that, climate change, they tend to talk about glaciers melting and oceans rising. And this is definitely affecting Iceland. They could vanish in 100 to 200 years. It's glaciers, which is not very much time if you really think about it. That's really fast, and that is potentially really scary, as, you know, the melting of these are just going to carve different, they're going to erode the land and create a lot of different runoff, just change the runoff, where everything goes, where the water's going to go in the country, you know. If it pushes it to somewhere people don't want it to be, that could be very bad for society in Iceland, and, I mean, this could be catastrophic, guys. Another thing that could be catastrophic to Iceland is ocean acidification. As the National Oceanic and Atmospheric Administration states, NOAA, ocean acidification is a reduction in the pH of the ocean over an extended period of time, causing primarily by uptake of carbon dioxide from the atmosphere. So basically, the more carbon dioxide humans are putting into the atmosphere, the lower the pH is getting in the water. There's going to be less fish, there's going to be less sea creatures, and 250 million years ago, something similar to this happened where the carbon dioxide levels got increasingly high. 95% of sea creatures perished. That's basically extinction, and that is very, very bad for the biological diversity on our planet. And we just hope and pray that we can combat these adverse effects to Iceland, and the ocean acidification and the glaciers melting could come with huge consequences. It's not looking good, and, you know, we need to do anything we can to stop these processes from happening. Guys, that is Iceland, a geologic look at Iceland, a very interesting country, very, very interesting. And I had a great time learning about it, I had a great time researching it, and hopefully one day I'll have a great time visiting it. Thank you guys again for listening, watching, participating along with me in Iceland, a geologic history. I am Julian Gauthier. I'll catch you next time.